Hi, so this is Module 2, Moderation and Mediation. So I wanted to just start off by talking about moderation and what is a moderator. So given that we had two predictors of y, for example, x1 and x2, moderation tells us that x1 alone cannot help us predict y, and that x2 alone can't help us predict y, but actually the combination of x1 and x2 serves as a predictor of y. And this interaction is saying that the omission of x1 or the omission of x2 does not tell the complete story of y, and that the combination of x1 and xy together are a significant predictor. So one way you can see how this works is by taking a look at the r squared. And when you look at x1 and x2 and the interaction as predictors, your model should explain more of the variance of xy. And we'll see examples of this a little bit later on. And it's also important to think about how the failure to include all relevant variables happens if you do not look into moderator effects, which can lead to biased estimates, which we don't want. But it's also important to recognize that the parameter estimates that we're getting are contingent on what variables are included in our model, given the regression equation gives us partial r's. So including the interaction term could lead to changes in the parameter estimates of your primary predictor. So if there's a significant main effect for the moderator, there will be a difference in the intercepts. We're looking at our graph, and in this case, there will be a difference in intercepts when looking at when looking at the groups of when our moderator equals 1 and when our moderator equals 0, because we used a binary moderator in this case. If there's a significant effect for the interaction, a lot of times there'll be a difference in slopes. And these patterns happen because the interaction parameter kind of fits into the simple slope and the moderator kind of fits into this simple intercept. So I created 3 different examples of moderation models using a continuous predictor and a binary predictor. So this is example 1. And you can see that we do not have a significant main effect for x1 or our moderator or the interaction. So before we even look at the graph, based on what I've learned about simple slopes and simple intercepts, the figure on the right kind of represents my rough estimate or expectation of what the graph will look like. So the intercepts will be the same and at 0, and there will be a slope of 0 for both groups. So we have 2 horizontal lines kind of on top of each other. And by rough estimate here, I mean very, very rough, and as if everything was positive. So this wasn't really meant to reflect the data exactly, but it was really just an exercise for me to help think about how these different pieces fit together and play out in graphs. And so when we actually look at our output and the graph that's generated in R, we do find that it's very similar to my earlier prediction. So for example 2, we see a significant main effect for the moderator, so the intercepts between groups should differ, but there's no significant effect of the interaction or our primary predictor, so the groups will have a slope of 0. And our intercept is significant, but B naught does not equate to 0. So when we look at the actual graph, again, we see very similar results. And lastly, for our third model, everything is significant, so we expect to see different intercepts that aren't equal to 0 and different slopes for each group, neither equaling 0. And when we look at our output, again, that is what we find. So example 3 seems to be our strongest moderation model and show the importance of not omitting relevant variables, considering indirect effects. By including the moderator, the regression equation explains over 90% of the variance in y. So now I wanted to move into talking about mediation. So when you're dealing with a mediator, you're actually looking at a causal pathway, and really an indirect causal pathway between x and y. So for x to cause y, x actually needs to act on a mediator first. And the x to y relationship is dependent upon the x to the mediator, the x and mediator relationship, and the relationship between the mediator and y. So as Barron and Kinney argue in their 1986 article, the terms moderator and mediator cannot be used interchangeably. Moderators must have direct effects and they affect the relationship between X and Y, while mediators are more of a kind of a go-between. With mediation, there's a causal relationship between X and the mediator, but with moderation, a causal relationship between X and the moderator is not required. Time is also another consideration. In mediation, X causes the mediator, and the mediator causes your dependent variable. In moderation, this isn't the case, and they can actually be co-occurring variables. And they might be correlated, but there is no causal relationship required where you see X precede the moderation. So moving into kind of testing mediation. So according to Barron and Kinney, there are a series of kind of checks that we need to assess when testing mediation. So the first is being the C parameter, and here we're wanting to see if there's a significant relationship between X and Y. But it's important to keep in mind that this could be insignificant later when we account for the mediator. And then when we look at A, we're looking at, is there a significant relationship between X and our mediator? And then we take a look at B and C prime. So we're looking at the relationship between our mediator and Y and the relationship between X and Y when we're accounting for the mediator. So then we kind of move on to the Sobel test, which requires us to calculate A and B and the standard error of A and B. And it's important to know that B is partial regression coefficient because we test B and C prime together. So the Sobel test is a way to assess whether the parameter between X and Y through our mediator is significant as an indirect effect. The number produced is actually a lot like a z-score. A p-value is assigned to it. And we use this to see if we can reject the null that the indirect effect is significantly different from zero. If we reject the null, we're saying that the probability of the data be observed given the null hypothesis is less than 0.05. So this isn't a test of mediation, but a test where we fail to rule out mediation. So we consider it as a potential effect in our model. But this can be problematic because when you're using the Sobel test, there's kind of an assumption of causality, but it relies on correlations, which really doesn't enable us to make strong causal inferences. Causal path significant test actually suffers from low power. The B parameter is a partial regression where X and our mediator are collinear, which means that we're dealing with high VIF and standard errors. And it also relies on the assumption of normality of our parameter estimates, but a lot of times it's not really realistic. So to address some of these power and normality issues with the Sobel test, we can actually use bootstrapping, which is a sampling procedure which samples where you sample at random from your observation, the same sample size that you've observed, then calculate mediation results and save them. So this is better than the Sobel because standard errors are an accurate reflection of the normal distribution of the estimated indirect effect. And Preacher and Haynes also note in their 2008 article how this technique is especially helpful when looking at multiple mediator models. So let's take a look at the first mediation example. So I started by looking at C, then A, and then looking at B and C prime, as suggested by Barron and Kinney. And as you can see, they were all statistically significant. Barron and Kinney might argue that this is enough evidence to fail to rule out mediation, but I also wanted to take a closer look by bootstrapping. And as you can see, there is a significant indirect effect. So in this case, we fail to rule out mediation. When you look at example 2, there is not a significant relationship between the mediator and X, and it didn't seem to be a significant predictor of Y. And the bootstrapping results seem to support these findings, with a CME having a narrow confidence interval near zero. So as far as implications, while I didn't find a mediated effect in example 2, the first example was actually a great example of how mediators kind of sit in between X and Y, and the importance of including relevant variables, as the model went from explaining 79% of the variance to explaining 99% of the variance in Y. So although I failed to rule out mediation, the X remained a significant predictor of Y. Again, when we're looking at that C prime, and when there's still a relationship between X and Y, even when the mediator is included, according to Kenny's webpage as updated in 2018, he would call this partial mediation. So I would hold on to X as a predictor rather than kind of ruling it out, which researchers might consider if there was a situation of pure mediation. And just lastly, I did look at the diagnostics for our moderation example 3 and the mediation example number 1, and I found that both models were blue. So that concludes Module 2. Thank you.